Hi everyone, this is Shobhitaa. In this video, I will be explaining the breadth first search algorithm as my assignment for the course Design and Analysis of Algorithms. Before starting with the algorithm, let's look at the structure of a graph. A graph is made up of a finite set of nodes and edges that connect two nodes. A graph can be directed or undirected. The edges of an undirected graph do not have a direction, while the edges of a directed graph point in a single direction. Breadth first search, or BFS, is a searching algorithm that is used for graphs. It answers two main questions. Is there a path between two nodes? And what is the shortest path between two nodes? Let's understand this topic through a simple example. This is you. Suppose you own a watermelon farm. You are looking for a seller who can sell you watermelons. To find a seller, you turn to Facebook. Are you connected to a watermelon seller? To find out, you start searching through your friends. These are your friends. Keep in mind that you and your friends represent nodes of a graph, while the connections represent the edges. First of all, make a list of all your friends. Now go to each person on the list and check if they sell watermelons. You have a simple yes or no question to ask. Does this person sell watermelons? Let's start with Jerry. Does Jerry sell watermelons? If yes, then congratulations, you found your seller. And if no, then you strike off Jerry's name from the list and move on to the next person, who is Minnie. Does Minnie sell watermelons? If yes, then you are done. And if no, we remove Minnie from the list and move on to Taffy. Does Taffy sell watermelons? If yes, then we are done, and if no, then none of your friends sell watermelons. Now your next step would be to search your friends' friends. Now you're not only searching your friends, but you're also searching their friends. Your aim is to find one watermelon seller in the network. So if your friend is not a watermelon seller, you add their friends to the list too. You keep on searching till you find a watermelon seller, or you have removed all names from the list. In that case, there is no watermelon seller in your network. Let's see an example of how you would go ahead with this. Does Jerry sell watermelons? If yes, then you are done. If the answer is no, then you add all of Jerry's friends to the list. In this case, we add Spike and Tom. Similarly, you will add Minnie's friends and Taffy's friends to the list too. Coming back to the two main questions breadth first search answers. The first question determines if a path exists between two nodes. This question can be reframed as, is there a watermelon seller in your network? We just saw how BFS answers that. Second question finds the shortest path between two nodes. This question can be reframed as, who is the closest watermelon seller? Let's see how BFS answers that. Your friends are your first degree connections, and their friends are your second degree connections. You will always prefer a first degree connection to a second degree connection, and a second degree connection to a third degree connection, and so on. Breadth first search radiates out from the source node, which is you in this case, and checks the first degree connections before the second degree connections. In your list of names, you will end up adding the first degree connections before the second degree connections. And if you follow the same order of searching, you will always find the watermelon seller who is closest to you in the network, if they exist. An important point to note here is that Tom is friends with both Jerry and Taffy. We are checking Jerry first. When we find out that Jerry is not a seller, we will add his friends to the list. By the time we get to Taffy, we have already included Tom in the list, so we will not be adding him again. While implementing this in the code, we will keep an array that keeps track of all the nodes that we have already visited so that we don't search the same node again. Why are we not checking the second degree connections before first degree connections? Let's assume that both Minnie and Daisy are watermelon sellers. If you check Daisy before Minnie, your search would be complete, but you will end up with a seller who is not closest to you. So it is important that you check the nodes in the order in which they are added. In other words, we can say that you are checking the node which is added first. So we need the first in first out property, and for that we can use a queue. Let's look at the time complexity of BFS. Let E be the number of edges and N be the number of nodes. Since you are searching the entire network for a watermelon seller, you will be following each edge, so the time complexity is at least order of number of edges or order of E. We are also keeping a queue, and adding an element to the queue takes constant time. Since we are adding at most n number of people to the queue, we get order of n. So the time complexity of BFS is order of n plus E, where n is the number of nodes and E is the number of edges. For the implementation of BFS, you can check out my blog. I have linked it down below in the description box. The example used in this video as well as the blog was inspired by Aditya Bhargav from his book Grokking Algorithm, an illustrated guide for programmers and other curious people. Do check it out for a more detailed yet fun approach towards algorithms. So that was it for the video. Thanks a lot for watching.